This video will look at the fourth and final method to solving quadratic equations, and that's the famous quadratic formula. So in Schoology, I did post a video with the algebraic proof of completing the square, and that is completely optional, but feel free if you want to see how or where the formula comes from, you can check that video out. So the quadratic formula gives us any solutions to a quadratic equation of ax squared plus bx plus c equal to 0. And that formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And the a, the b, and the c are your coefficients in your general equation, right? ax squared plus bx plus c. So in trying to solve 3x squared plus 2x minus 1 equals 0, let's identify our a is equal to 3, our b is equal to 2, and our c is equal to a negative 1. Now you're just doing or plugging in those numbers straight into that formula. X is equal to negative b is a negative 2 plus or minus square root of b squared minus 4 times, it helps me to put parentheses around everything, a, which is 3, and c, which is negative 1, excuse me, and that's all over 2 times a, which is 3. And now we're just simplifying, right? X is equal to negative 2 plus or minus the square root of 4, and then minus 4 times 3 is 12, minus 1, that's going to work out to be a positive 12, and we're still over 2 times 3, which is 6. Continue to simplify, negative 2 plus or minus the square root of, love it, 16 over 6, which is negative 2 plus or minus 4 over 6, and our two solutions would be negative 2 plus 4 is 2 over 6, which is 1/3, and negative 2 minus 4 is negative 6 divided by 6 is negative 1. And there's your two answers, 1/3 and negative 1. So whenever underneath the square root works out to be a perfect square like it did in this case of 16 or let's say 25 or 49, that tells you that your original quadratic was factorable. And our factors would have been 3x minus 1 and x plus 1, and if we solve that equal to 0, I'm sure you're surprised we're getting 1/3 and negative 1, which was our same answers using the quadratic formula. So now when it comes to solving quadratic equations, you should be comfortable using any of these methods. So if I ask you for a specific method like completing the square or the quadratic formula or factoring, you should be able to do that. And then also, given your own choice, choose with whichever method you like. But I want to go back and talk about what I talked about right here, which was that value under the square root. That's going to tell us a lot about the types of solutions we're going to get. And what that is called, right, our b squared minus 4ac, and let me come up here, right, here's our b squared minus 4ac, and it's what's underneath the square root. That's called the discriminant. And think about when you have the square root of some number, right, it depends on what that number is. If that number is negative, right, you can't take the square root of it. You will have no real solution. We'll get to imaginary numbers later, but if you have a negative discriminant, you'll have no real solution. If your discriminant is equal to 0, what's the square root of 0? It's just 0. There's only one answer, so you're going to get one solution. And then if your discriminant is a positive number, whether it is 16 or whether it is 37, you are going to get two distinct real solutions because both of these will have a plus or minus value to them. So look at these examples right here, right? Let's use the discriminant to determine how many real solutions there are. So in A here, let's first identify our A, x squared is 1, our B plus 4x is 4, and our C is negative 1. Our discriminant, right, remember that's always b squared minus 4ac. It's what's underneath the square root. That's going to give us what? 4 squared is 16 minus 4 times 1 times negative 1. That is 16 plus 4, which is 20. And 20 is greater than 0, so that means we're going to have two real solutions. And what does distinct means? Means two different, right? Real solutions. How about B, right? Let's determine our A, B, and C. A is 4, B is negative 12, and C is 9. Our discriminant is equal to B squared minus 4 times A times C. This is going to give us negative 12 squared is 144 minus, and how about what is 4 times 9? Aha, it's 144. So this will equal 0. We will have one real solution for this quadratic equation. And then finally, our last one, our A is 1, our B is 4, and our C is 5. B squared minus 4 times A times, C is equal to 16 minus 20, which is a negative 4. Ding, ding, ding. Our discriminant is less than 0. We will no real solutions. So remember that discriminant is really important in telling us what types of answers we're going to get. And again, the discriminant is the part that is underneath the square root. It does not include the square root. And let's do one more thing and look at a problem that can be written in a quadratic form. You've seen these before. Remember when we change, I think I was changing it to p squared and p. This example is using w's, right? So here we have x to the 4th minus 8x squared plus 8, right? It kind of looks like a quadratic, except that we've got 4 and 2. But remember, on the side over here, we could say, let's let w equal x squared. And we can now rewrite this problem. This problem will become x to the 4th is really w squared minus 8x squared. We could change to 8w plus 8 is equal to 0. And now let's talk about using the 4 different methods for solving this quadratic equation. Remember, first was just looking at it simply. Can we square root both sides? Well, no, we can't in this case. Our second method was to factor and then use the zero product property. So how about, can we factor this? Well, we would need two things that multiply to be 8, but add to be negative 8. That's not going to happen. So let's move on. Our third method was completing the square, and our fourth was using the quadratic formula. I put these two together because you could choose either of these methods if both simple solving and factoring don't work. It's up to you with which method you prefer, unless, of course, I'm asking you to show me a specific method. I'm going to use the quadratic formula. We're going to use negative b plus or minus the square root of b squared minus 4ac over 2a, where a is 1, b is negative 8, and c is positive 8. If I plug them in, I've plugged in my values here, simplifying it into 8 plus or minus the square root of 32 over 2, and we can continue to simplify that into 8 plus or minus 32 is 16 times 2, so that will be 4 radical 2 all over 2, which we could further simplify, right? I can cancel 2 into both the 8 and the 4, so that will leave me with 4 plus or minus 2 radical 2. And you might think that's my answer, but it's not, because I actually have a mistake, or not really a mistake, a typo or a way of thinking about it. Because remember, we changed x squared, right? We changed the x into w's. And really up here where I have x equals, that isn't what I should be solving for. Remember, we changed everything to w's. So here, instead of x, I should have a w equals for my quadratic formula. And in fact, so all of these right here, w, and in fact, this would be w equals 4 plus or minus 2 root 2. And then remember, what did w equal? it equaled x squared. So I can rewrite this as x squared equals 4 plus or minus 2 radical 2. And now what do we do to solve this? Well, yeah, we have to square root, and don't forget, it generates two solutions, so we need that plus or minus in there. And what is this going to give us? Well, it'll give us x equals plus or minus the square root of 4 plus or minus 2 radical 2. That's different looking. And that is exactly how I would leave my answer. Don't try to square root within those square roots. I would leave it as this form right here. So you now have all 4 techniques for solving quadratic type equations: simple, factoring, completing the square, and using the quadratic formula. And we can even get a little more advanced by changing something that looks like it's a quadratic type and getting a pretty complicated solution. So now go ahead and try the whisk, and I'll see you soon in class.